Okay, so in this video we're going to do 73, 84, and 87 from chapter 3. I'm going to do number 83 on a different video because I want to make sure it doesn't get jumbled in with the rest of the homework. So if you just need 83, go to the next video. Okay, so 73 is in a standard deck of 52 playing cards, 13 cards are clubs, and 3 of the cards are face cards. So J, K, and Q. What is the probability of drawing one card that is a face club or a club or a face card, I should say? Is this event a union or an intersection? So I was trying to rack my brain really quickly of trying to give you the best way to explain this. So this is the part of probability that cards and I don't really get along very well. Okay, so you know, this is how we're going to have to do this. So the probability of a club or the probability of a face card, and then we're going to have to subtract out how many of them are clubs and face cards. So we don't have an area model to do an OR for this, so we're going to have to do this the way that the book kind of describes it. So I'm going to say probability of event A happening plus the probability event B happening, subtract out the intersection of probability A and B happening. Okay, and this will make more sense when we do this, because there's a bunch of clubs that are actually face cards too, so you can't double them up. You cannot just add 13 plus however many face cards you have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can't just add 13 plus 12 and then say, oh, okay, that's all of them together. A bunch of clubs and face cards, because there are some clubs that are face cards. So, and there are 3 of them that are double. So you're doubling up, technically by not doubling up, you're adding 3 one too many times. So the way that this is going to go is probability event A, probability of it being a club. So we have 13 clubs, and then how many face cards in a deck of 52? So there's 4 suits, so each suit has 3 different face cards, so that'll give you 12 total face cards in a deck of 52. And then subtract out how many of them are clubs and a face card. Does that make sense? So how many of them are clubs and a face card at the same time? Technically, there's only 3 of them, because there's 3 clubs that are also 3 face cards. So we have, what do we have? 25 minus 3. So technically that gives us 20, oh my God, I'm drawing a blank, 22 cards, right? So 22 cards is what we're left with, but we want the probability. The probability would be 22 would be 22 out of 52, and I'm pretty sure you can find out what the percentage of that is. Okay, so you have 22 cards that are face or club, and the event is a union of the 2. Okay, a club and a face card, which is what we just did. So how many are clubs and also face cards out of the 2, out of the suite? So you technically have 3 out of 52 cards, which is what I just talked about over here. And then the rest of them that are not a club and not a face card, well, I'm not going to sit here and try to calculate the whole thing, but I do know if it's a club and a face card, it's 3 out of 52. So if I take away 3 from 52, I should be left with 49, ideally. So that means 49 cards. Everyone else who's not a club and not a face card, it would be 49 of the cards. 49 out of 52 gives me the probability of it being not a face card and not a club. All right, 84. Expected value. So we're going to set this up really quickly. This is 90 out of 360. These 2 are equal, and I'm pretty sure. So if I take 90 out of 360, subtract it from 90, I get 270. Well, these 2 are even, so if I cut 270 in half, I get 135 for each. So 135 degrees, 135 degrees. Whoopsie, that's degrees. Okay, so that's out of 360 also, and that's out of 360 also. So the setup for this expected value would be 90 out of 360 for -6, plus 135 out of 360 for $3, plus 135 out of 360 for $5. Okay, so just calculate what is the actual expected value per game for this. And then the question is the game fair? The game would be fair if the expected value was equal to 0. So the question is your expected value equal to 0? If it is, then your game is fair. Nobody lost anything, nobody won anything. But if it's not, then you have to calculate your losses or your gains. Okay, 87. So for number 87, you should have a pretty good idea what to do. Just put them equal to each other, find the value of x, plug it back in, find the value of y. This one, though, I'm going to do the setup for this. I'm not going to do the whole way. This needs to be done by substitution because it's just faster that way. Okay? And by substitution, I mean everywhere where there's going to be an x, if x is equal to -2y minus 1, where this x is, I'm going to take this whole quantity and plug it in for that. So this should look like 2 times something plus y equals -20. So the value, -2y minus 1, goes inside the parentheses. Then I get -4y minus 2 plus y equals -20. And then pretty much just solve what, technically there's a 1y there. You can put that together. -3y minus 2 equals -20. And then solve for y, right? Get a value for y. Take it, plug it back in. I don't care which one you plug it back into, but get a value of x also. You need both of them. Okay, so that's this video. If you have any questions, please see me outside of class. Thank you.